Audio Jungle.
Assalamualaikum and hi to Prof. Madya Dr. Dr. Muhammad Sohu. My name is Muhammad Fikri Muhammad Shukri, Major Number CE1 and 042. My group members is Muhammad Hakimi bin Uthman and Muhammad Faris bin Hairani. So for my part, I will explain about the simulation circuit of the DC to DC boost, which is boost from 12 volt until 24 volt, also from 12 volt until 50 volt. So for the circuit, we are require several components, which is the DC to DC source voltage, inductor, MOSFET switch, diode, capacitor, resistor, and um, voltage measurement, current measurement, Augury duty cycle, pulse width modulation DC to DC, and the scope of waveform output display, and the display of voltage output. So firstly, for the circuit, we need to set the input voltage to 12 volt and the inductor to 36 microhenry and the capacitor to 217 microfarad and the resistor to 11.52 ohms, and the duty cycle is set to the 0.5 duty cycle. So for the simulation of this first simulation, which is in the inductor value of 36 microhenry, the output boost that have been produced is 22.95 volt, which is precisely equivalent to the 24 volt. So the output waveform is here. Here is the output waveform of the first circuit of 0.5 duty cycle with inductor of 36 microhenry. As you can see over here, this is the signal of the pulse width modulation generator that has been fed to the MOSFET switch to turn on and turn off. Okay, so this is the output waveform of current measurement, which is the inductor current, and this is the output waveform of the voltage measurement, which is the voltage output. So this is the circuit of the first circuit. So for the second step, we need to boost from 12 volt to the 50 volt, which is we need to change the value of inductor to 10 times from the actual value, which is 360 microhenry, which is over here. And we also need to vary the duty cycle from 0.1 until 0.8. So the inductor has been changed to 360 microhenry. And for the duty cycle 0.1, the output voltage that has been produced, the output boost voltage that has been produced is 12.53 volts. So the output waveform is over here, which, as you can see over here, when we set the duty cycle into 0.1, the pulse width modulation signal that have been fed into the MOSFET switch is very small, which is it just on in a small less time, a short time, but off. It is be on in a short time but off in a long time. So for the next circuit of 0.2 duty cycle, okay, the output waveform, output boost voltage that have been gained is 14.18 volt, and the output waveform is over here, where as you can see the pulse width modulation signal that feed to the MOSFET switch is much bigger than before, where the MOSFET switch is on much longer than before. Okay. Then for the duty cycle of 0.3, which is here, the output they have been gained is 16.3 volt with the output waveform of this. When the duty cycle is increased, the waveform of pulse width modulation signal that has been fed to the MOSFET switch also will be increased. As you can see over here, it is much wider than before, where the MOSFET switch is on much longer. Okay, so for the next For the next duty cycle is 0.4, which produce output voltage of 19.08 volt, and the output waveform is here, where as you can see over here, the pulse width modulation signal that fit to the MOSFET switch is much bigger than before. Then for the duty cycle of 0.5, which is over here, the second, okay, produce the output voltage of 22.9 volt with voltage out with output voltage waveform. Yeah, I'm sorry, with the output waveform over here, which is the, as you can see over here, the pulse width modulation signal that has been fed to the MOSFET switch is much wider than before. Then for the cycle 0.6, where the output voltage is 28.43 volt with output waveform, the pulse width modulation signal that fit to the MOSFET switch is much wider than before, where the MOSFET is being turned on longer than it is being turned off. Okay. So for the duty cycle of 0.7 over here, the output voltage is 36.95 volt with the output waveform of this output waveform. For the pulse modulation outputs, pulse modulation signal that have been fed through the MOSFET switch, it is much wider than before, so it is turned on much longer than before. So lastly, for the duty cycle of 0.8, which produce output voltage of 50.79 volt with the output waveform, yeah, as you can see over here, the pulse width modulation signal that feed to the MOSFET switch is much wider than before, which is the MOSFET is being turned on much longer than other duty cycle. So what I can conclude over here is, when the duty cycle is being set up increasingly, the waveform of the output, the waveform of the pulse width modulation that have been fed to the MOSFET gate is also much wider. Okay, okay, that's all for me. And also, I'm sorry, and also when the duty cycle is set from 0.1 to 0.8, when the duty cycle is increased, the output voltage also increase, where it is from 12 volt until 50 volt. Okay, that's all for me. Thank you.